Okay, hello again. Uh, let's start. Um, First things first, we have to congratulate Patroklos and his great team for the Devoxx here today. I think it's an amazing event, as always. Second thing, my name is Vassilis, and I'm from MindWave. Third one, my mom is called Melina. Uh, you will be thinking why I'm mentioning this. I'm quite old, yeah, I know to say this. But I would like to start with a story that I think that it is pretty common, pretty popular to most of you. How many of you can remember their parents, mom or dad, complaining about the lamp switching off? Yeah, raise your hands, unless we have too many rich people here. I'm going to say to Patroklos this, and are going to have increased tickets next year, guys. So don't sigh, raise your hand. Anyway, it was always a nightmare, I think, to forget the lights switched on. And anyone can remember the phrase, switch the lights off, or else we are going to pay a huge amount to the electricity provider here. I can assure you that even when I grow up, I still come up with such cases. There are still adult people doing this to adult people. Can you imagine how they are called, these people? CEOs, investors. Yeah, you may don't like them, but they have for sure something in common with mom and dads. They have the money and they pay the bills, right? So in our case, we have a customer who has a wind farm, and this farm consists of many wind turbines. These turbines produce energy. However, these turbines, in order to be functional, consume also some energy, and generally the whole park consume energy, and this can be harmful, especially when we have days with low wind. So here comes again the phrase, switch it off, or else we are going to pay a huge amount. So we started designing a solution for an automated system for the whole switch on and switch off thing. But guess what? CEOs, yeah, you like them, and investors are like moms. Let me explain. During the Christmas period, my mom always decorates the house with a lot of lights, and she insists that they are switched on the whole night, the whole period. It's the same person that was complaining about one single lamp, right? So reading and understanding the requirements, it's really difficult. So in our case, when we have that kind of unpredictable and versatile context, such as weather forecasts, energy prices, it's really, really hard to automate everything. For this, we decided to move forward and build an autonomous system, actually an autonomous mom that can think, decide, and take action on its own while adapting and responding to environments, changing environments, contexts, and scenarios. And we moved to this solution. So here you can see that we integrated the basic ingredients of any autonomous system. We have the AI for logical thought and reasoning, decision taking, and action triggering. We have the sensors technology. It's the senses of the AI, the eyes and the ears. And finally, we do have the connectivity. Connectivity not only matters of communication, but providing also tools and function through the modules, to the one to another, so that these tools can be used by different modules. In this diagram, you can see that we do have the turbines. They are connected to the PLC. We have also the sensors connected also to the PLCs. They can publish data to an MQTT broker. And from this MQTT broker, they can also receive commands in order to operate. The data, as you can see, are synced in our data lake and stored there. Next, we do have the backend service. The backend service is the service that provides the implementation of the required tools. You are going to understand what exactly tools means. The backend service also provides the integration with the AI LLM service. It can also provide integration with external services such as APIs. And finally, it initializes the AI agent that we need, because simple LLM integration is not enough for our case. We will explain this. Now, the central module is the AI LLM service. This service can be prompted by the business backend service with a main question, and this question is also accompanied with a suite of tools, functions that the AI LLM can use in order to get the knowledge that it is required to answer the question. Let's go to an example in order to understand how the whole thing works. So we said that we need to decide if we should switch on or off the turbines based on some context, based on some instruction. So now, if you go to the ChatGPT and make this question, should I switch on or off the turbines? It will most probably always kindly, that's a good advantage of ChatGPT, will say that it is going to say that, I'm sorry, I cannot answer your question. That's why we need to provide also some tools to the AI LLM from our own internal infrastructure, so that it can select which of them should be executed, get the results back, and then, if it is able to answer the question based on the results, we are going to have a final answer / command that is going to be sent to the turbines. For all these, we need task chaining and modularity. We need to handle complex workflows through orchestration and persistent state management, which is better suited for that kind of applications. In order to orchestrate the whole process, we need to create the AI agent that I said before, and we're going to use a graph-based orchestration tool to explain easily to the LLM through a graph how it can find the required knowledge so that it can answer the question. For this, we are using LangGraph. LangGraph is a stateful orchestration framework that brings added control to agent workflows. So here, we do have a simple LangGraph diagram. This is what we are going to demonstrate today, quickly. So as you can see, we have 3 nodes. We have the LLM node. Here we do start. We ask the LLM to take the decision. And what the LLM does is checking if it can answer this question. If it cannot, it goes to the second node, the action node, and requests to this node to execute some specific actions. So the LLM is not only able to understand that it needs more context, but it is also able to understand which functions are needed to be run, to be executed in order to get to this result. So the action node then gets the results and returns the results back to the LLM. The LLM then again makes the same question. Can I answer the question? If yes, then we are moving to the end node, the third final node. If not, it can iterate as many times as needed. In order to be more clear, let's see some code. So I have already executed. Let's start from this, and we're going to see line by line the code. but I think that it would be more understandable if we go to the final result. So we do have the first question. The question would be simple: should I switch on or off the wind turbines? As you can see here, we are in the LLM node, the first node, and the node decides that we need to execute some tools. And the tools is, it's actually just one, they get instructions for turbine function. So it needs some context, and it is requesting for this. This tool is requested, as we said, from the action node. The action node executes this function, and the answer is this. All this answer is then sent to the AI LLM service. The LLM service reads these instructions and decides that in order to decide if it has to switch off or on the turbines, it needs the current wind speed and the current energy price. Again, the action is calling these two functions. It says that the wind speed is 9. It says that the price is 99 euros per megawatt hour. And then these answers are sent, of course, to the AI, and the AI LLM service can then make a final statement. So the final statement is the current wind speed is 9, and the energy price is 99, according to the guidelines that I have already got. Since the wind speed is above 7 before, we need to consider the energy prices. The energy price is less than 100, so you should deactivate the turbines. Let's go and see some code here in order to understand how exactly and what happens in the backend. So here, I just need to initialize a rack system. I'm not going to say a lot about this, but think about it as a database where we can store documents, text, as vectors, and there we can run some similarity checks and retrieve, based on this similarity, the most similar text. So what we are doing here is that we are taking a piece of documentation of our customer exactly as it is. We don't need to change this. We don't need to translate the requirements. We are getting this as it is. And we are storing this text to our RAG system. This text is actually a description of how exactly the turbines can operate. And we can also pass here, we can see that we pass here some rules. So we need to activate the turbines if the wind speed is between 3 and 7 before. We need to deactivate the turbines if the wind speed is less than 3 before. So for wind speed exceeding 7 befores, we need to consider the energy price. If the energy price is less than 100 euros per megawatt hour, deactivate the turbines. If it is greater, then activate the turbines, because there is a profit. We can sell in a good price. If not, there is no reason to consume energy. So having this information directly to our RAG system, to our database, then we can build our own infrastructure in the backend. So here, for example, we have 4 functions. The first one is the get instructions for turbine function. It pretty much runs a similarity check and returns, of course, the text that we have already read. The other function is the get wind speed. So we have a client to our data lake which can run the queries and return the latest wind speed. The get current temperature, the same as the previous one, but it returns the temperature. And we also have the get current energy price. This entry client is an API client. So what it does when it is triggered is going to an API and gets the current energy prices. As you can see, this can be any function that you already have in your organization. Okay, it's something that it is based on your business. And these exactly functions that are already there, or they're easily to, you can easily create them, implement them, can also be the tools that we were saying before. Easily with these tools that, and libraries that we are using. And for example, here, let's go and see how LangGraph works and how we can create an agent. So here we have the constructor of the agent. We need to pass as arguments the model, the tools. It's an array of functions, think about it like this, and the system. The system is just a simple text, the basic first text that we're going to send to the AI in order to have a first understanding of what is expected from it. So we are doing the initializations here, and we are initializing our graph. It's quite simple, that's why we choose this framework. And we can add a node. Let me show you one more time. We have 1, 2, 3 nodes. We have one condition edge that goes either to action or to the end. And we have one more edge that moves from action to the LLM. So here we are adding the LLM node. When we are in this node, we are running this function, the call OpenAI function. Can you read it? Is it? Do you know the shortcut? PyCharm? Let me check if I can visualize it. Okay, Alt-Shift plus. Doesn't work. Let me do it one more time. Okay. So when we are in the first node, in the LLM node, we are calling actually the LLM. Here we are. So we gather the messages that we already have. We said that we required a state in our case. And we are invoking the model. We are getting the result, and we are then pass it to the next node, to the action node. The action node, when we are in this node, in the action node, we are actually taking action. Again, simple function. We are looking for the latest message that we received from the AI. This includes the tools, and for each tool that it is included in the answer, we are executing the function, the tool that we have already built. Finally, we have the two edges. One is the conditional that goes either to true, to action, and if this falls, to the end. The answer to this is given by this function. For this function, we are getting again the latest message, and we are checking if we do have tools. So if the AI requested a tool, then we are moving to the action node. If not, we are returning to the final end node. That's it. We are setting the entry point to the LLM. We have the graph compiled. We initialize the tools and the model. So here, when we run it, this is the prompt that we are adding in the beginning. You are a smart assistant. You may already be familiar with this. Always be kind to them. You don't know. And finally, we are requesting to add the last statement which clearly answers to the question received. So here we're initializing the model. It's 4.0 mini, the GPT 4.0 mini. We're initializing, we are calling the constructor that we created before. So we do have now our autonomous mom. The query would be simple. Should I switch on or off the wind turbines? And we invoking this graph. So our agent is ready. Let me run it one more time. Let's hope that the internet is okay. So again, one more time, we have the question coming to the LLM. The LLM decides to get the instructions. The action node is returning the instructions. The LLM then asks for some more information. It says that it needs the before the wind speed and the energy prices in order to be able to answer. These values are returned to the LLM from the action node, and then we do have the final result. So let me quickly change our RAG system and add one more line. Let's say now that our CEO, our investor, has a new rule. Look how easy it is and how easy the LLM is going to respond to it. So as a final important rule, you need to take under consideration the current temperature. If current temperature is less than 0, the turbines must be deactivated regardless of the wind speed and energy price in order to avoid damage because of frozen conditions. So if we rerun this, you see now that the LLM requires also the temperature. So it uses the other tool that before it wasn't needed, and that's why it never asked about this. So the temperature now from our source is -5. These are sent back to the model. And given that the temperature is below 0, the turbines must be deactivated regardless of the wind speed and energy price. Therefore, you should switch off the wind turbines. So this is an example of how the data evolution is transforming the industries from early databases, management systems, and more recent systems with advanced analytics. The power of the data is driving always the industries. Now we are without doubt in a new area, in the early ages of a new era where we are moving from automated systems to more autonomous systems. This is a real scenario that we faced, not exactly, of course, like this. And we prepared a real POC that is still being used for pitching and sale purposes with really positive results. So as you can understand here in MindWave, we are ready for this new era and the challenging journey. We want to remain a key player in the technology industry. And with such solutions, you need no more to worry about the translations of the requirements, the business requirements into code, as this can be passed directly to the AI LLM. And of course, use its reasoning capabilities. The only, of course, thing that you still can worry you is taking, guys, your jacket with you when you leave the home. You don't want to mess with moms, believe me. And unfortunately, I don't have any answer or solution about this. Thank you.